Hi, this is Dr. Green. We're working on Web Assigned Homework 8 and problem number 7. So in my example here, we got a psychologist who's studying drug addiction, and they test whether a group of treatment, whether group treatment participation and relapse are independent. And so they list the observed frequencies down here in this table, and what they ask us to do down here is conduct a chi-squared test for independence. So that's a different type of chi-squared. We're not testing against a distribution, we're testing to see if things are related or if they're not related, if they're dependent or if they are independent. So if we go to our formula sheet here, you can see this was the one-way table, goodness of fit. And down here we have a two-way, what's called a two-way or contingency table analysis, and that's for a test of independence, chi-squared test of independence. So our null hypothesis is that the two characteristics are independent. So for us it's going to be treatment and relapse. And the alternative, if we reject the null, is that the two characteristics are dependent, okay, that relapse would depend on group treatment. And you can compute a chi-squared test statistic similar. It's the exact same formula, okay, except a little bit different way to get your expected counts. And you do it from a two-way table. So we did that already with the goodness of fit test here. So I'm going to show how to do this in SPSS rather than doing things by hand. So first of all, I want to code this data into SPSS, and I will just note that the SPSS steps are down here. And so those are on the handout, and I will just help you work through them here. So I've already coded the data into SPSS. So here's how the data looks in SPSS. I've got three variables here. I've got two nominal variables, which are the status of treatment and the status of treatment, and then the status of relapse here. Notice I've coded them with 1122 and 1212. So what's going on there is I'm going to, we're going to ask, were they treated? Yes, we're going to count that as group 1. And then no, we're going to count that as group 2. Did they relapse? Yes, we're going to count that as group 1. No, we're going to count that as group 2. So if we go down here and look at the variable view, you can see that this variable has some values that are coded in here. So you want to list, what your characteristic is, treated and relapse. And then these are going to be nominal variables, so they'll be nominal variable type here. Right here. And then we've got under values, they'll be coded in, and you want to click there and click the drop down and then type 1 for value and yes, and click add, and then click 2 for value and type no and click add, and then these will appear down here. So 1's coded as yes and 2 is no, which is what we have here. 1 is yes and 2 is no. And then we did the same thing for the relapse here, the relapse status. We coded 1 for a yes and 2 for a no. And that makes sense here. 1 was a yes, 2 was a no. And then we enter in the counts. So yes, they were treated. Yes, they relapsed was 11. So let's go back to our data view. So yes, they were treated. Yes, they relapsed. That's 1 and 1, 11. Yes, treated. No for relapse. So that's a 1 and 2, 23. So 1 and 2 here in the second row, 23. No, they were not treated. 2, yes, they did relapse. 1, so that's a 2 and a 1, 18. 2, 1, 18. and then no, they were not treated, and no, they didn't relapse. 2 and 2, status 2 is 13. So 2 and 2, 13. So that's how we code the data in. And then once we do that, we have to do the weight cases again like we did before. So we have to go to data and weight cases all the way down to the bottom. And oops. And then we are going to weight cases by the counts. And click OK. Come back to our data here. And then we are going to go to Analyze, and then Descriptive Statistics. And then we're going to go to Crosstabs. And that'll give you this window. And then inside that window you want to click on well, you want to bring over your row and column variables. So whether or not they were treated, that was our row variable. Whether or not they relapsed, that was our column variable. Come on over there. And then click on Statistics. That gives you this dialog box. And then you just want to click on chi-squared. Then click Continue and click OK. So then that gives you this output. So we've got case processing, just telling us we process 65 different cases. The cross tabulation table, so this should look exactly like your original table. If it doesn't, then you made a mistake. So I took this and I brought it over to the document. That's right here. And notice that that's the same as this. And then the chi-squared test output, that's this next one down here. So I took this table and I brought that over here. So now we are wanting to know, do we reject the null hypothesis? Well, we've got a test statistic here, and we're using the first row here where it says Pearson chi-square, because we're doing a chi-squared test of independence. We got our test statistic right here, which is the chi-squared, so that's the chi-squared value, and there's a star by it, superscript by A, and it says here, note 0 cells had an expected count less than 5. So these were our expected, these are our observed counts. Our expected counts are when you multiply by the multiplied by probabilities based on this table, and it says none of those things were less than 5, which is an important condition. If you get one of them that's greater than 5 in practice, then you want to take a good look at your data and see if you can't use different data or add to the data, collect more data to make sure you don't have a count that's less than 5. And then what we want to do to make the hypothesis test is to look at this p-value right here. Okay, that's a two-sided asymptotic significance. Significance is always your p, and our p, two-sided p, is 0.037, and that is less than 0.05, so p is less than 0.05, and we are conducting the test at the 0.05 significance level. They ask us for our chi-squared value, so that's the 4.338. We're rounding to 2 decimal places, so this would be 4.34. And then our p is less than 0.05, so we are going to reject the null hypothesis. Okay, and that's SPSS for a chi-squared test of independence. In part B, they want us to compute the effect size here using phi and then what's called Kramer's V. And they tell us that both should give the same effect size. So here are the formulas for phi and then Kramer's V. You put in the test statistic, divide by the total sample size, and take the square root. So remember, our test statistic here was the 4.34. So this is going to be the square root of 4.34. And we don't square the 4.34. That is chi-squared. Okay, the square is part of the value. And then divide by n was our our total of all cases, which is right here, 65. So we divide by 65. And then if you plug that into the calculator, round to 2 decimal places, because they want 2 decimal places here, that's 0.26. And so that's phi. And then Kramer's V, we do the same thing. We've got that chi-squared up on the top, 4.34. And then you divide by, now the 65 times the smaller degrees of freedom. So the 65 here, and then your degrees of freedom are 1 less than the number of rows and 1 less than the number of columns. So we got 2 rows and 2 columns. So the 2 degrees of freedom that we are picking between are 2 minus 1, which is 1, and then 2 minus 1, which is 1. So they're both 1. The smaller of 1 and 1 is 1. And that's also going to give us that same 0.26 if we round to 2 decimal places.